Okay, solutions to diagnostic. Question 1. A particle displaying simple harmonic motion has a displacement modeled by this function. So what it means is x versus t, we're going between 8 and minus 8, starting at the maximum because it's a cosine function, and the particle is doing something like this over and over again. We've got a 4t there, so our period is 2 pi on b, so 2 pi on 4, or pi on 2. It's doing that. Question didn't ask me to draw it, but just to get my head around what's going on here. Okay, part A, find the velocity function and hence the maximum velocity. So I know to find velocity, it's going to be the derivative of the displacement. Okay, I could have written this as dx dt if I wanted. Either way, works okay. So I'm trying to differentiate 8 cos 4t. So 8 times 4 is 32, okay, because I need to multiply by the differentiation of what's on side. Cosine changes to negative sign, and we keep that 4t there. So that's what my velocity function looks like, and hence find the maximum velocity. So I know the max value of sine is 1, okay, or negative 1. So the velocity will be between minus 32 and 32, because it's going to be minus 32 times 1 or minus 32 times negative 1. If I wanted, I could also show this in a graph, that I've got 32 and minus 32, just to show my understanding. So in this case, my max velocity is 32, whatever units they are. Does it have units? No, let's just assume meters per second. Okay, find the acceleration function. I know my acceleration function is the derivative of the velocity function, so I need to differentiate this guy. So again, 4 times minus 32. It will give me negative 128. I know that sine just differentiates to cosine, and the 4t is still there. Okay, that's my acceleration function. Find the first 2 times when the particle is at rest. Okay, at rest. So I need to find, and I'll write this in my solution, find when the velocity is 0. There's my velocity function. So that is when 0 equals minus 32 sine 4t. I'll divide both sides by 32. And then I'm looking on my unit circle for where the y coordinate is 0. So it's 0 at 0 and 0 at pi radians. So the angles I'm going to get will be 0, pi, so here, here, and then I can go around again, 2 pi, etc. Okay, but remember, this isn't the time, this is 4 times the time, because that's the angle that I'm trying to find. So to find the times, divide everything by 4. And that would be the first 3 times. I'm only after the first 2 times, so I'm just going to choose the first 2. Okay, part D, find when the particle next reaches its maximum displacement. Okay, so 2 ways you can go about this. Maximum displacement. If I remember my formula for displacement, 8 cosine 4t. I know the maximum displacement will be when it's either negative 8 or 8. okay, which we can see on that graph that we drew originally. The furthest away it gets from the origin is at 8 or minus 8. So I can substitute in 8 or minus 8 in here and find t. Okay, so I put an 8 in here. 8 goes 4t. I'm then looking at where does cosine 4t equal 1. And I can do the same thing with a negative 8. Okay, where does cosine 4t equal minus 1? So looking at my unit circle, looking for an x-coordinate of 1 or minus 1, it seems to be at these same 2 points, 1 and minus 1. Okay, so over here, 4t for the positive will be at 0, 2 pi, 4 pi, etc. Here's the point. I can go around another 2 pi, another 2 pi, etc. And for the negative one, 4t will be pi, 3 pi, 5 pi, etc. Okay, so the times when we have the maximum displacement would be 0, pi on 2, pi, etc. Or over here, pi on 4, 3 pi on 4, 5 pi on 4, etc. So it was a question, when the particle next reaches its maximum displacement. The reason why it says next here is because it started at its maximum displacement. Where's this next point down here? It must be the one closest to 0. Yeah, this pi on 4. So I could write some comment like that. Alright, the alternative way you could have solved this is to find the maximum displacement. Okay, it's another way of asking find when the velocity is 0, because we know that when these particles get to this endpoint, it's essentially stationary before it starts accelerating the opposite direction. Okay, so 2 different ways you could have gone about that problem. Question 2, using Trapezium method with 5 strips, evaluate this definite integral. Good idea to just have a graph of it to see what it looks like. So there's a lot happening in the negative x-axis, but in positive x-axis, not much at all. So we're asking between 4 and 6. We're trying to find what this shaded area is. It says Trapezium method using 5 strips. So the width of these strips, it's between 6 and 4, and we're breaking it into 5 strips. So the width of each of these strips is going to be 0.4. Okay, I know my formula for area is W on 2 E plus 2M. So I know the width of each strip is 0.4. I need to find what's the height of these endpoints for E, and what's the height of the points in the middle for M. Okay. The way we'll go about this is, well, I know I need to be between 4 and 6, so I'll make a little table with these values. So 4, 4.4, just adding 0.4 at each step. Okay, is this going to get me 5 strips? There's 1, there's 2, there's 3, there's 4, there's 5 strips. Sounds good. So these are all the x values. I need to find what the y values are. So I'm going to substitute all these x values into my function, x squared plus 4x plus 2, to find the y value. So in here, it'll be 4 squared plus 4 times 4 plus 2. Okay, so we get 34 here, and you can complete the rest of the table substituting in the other one. Okay, by doing this, we've essentially found the height of all of these strips. So we're making that shaded area into a trapezoid like that. Alright, I know my endpoints are these two. So So 34 plus 62. And my midpoints are all of these. This is all my middle heights. So I'll add together all of these. So it might be a little bit of rounding here. We're not expecting everyone to get exactly the same value. Now that I've found W, E, and M, I can go ahead and use my trapezium area formula. So I'll rewrite it just so I don't get lost along the way and substitute in all these values. And I'll end up with an area of approximately 94.72 units squared. Okay, that's trapezium rule. If I wanted to check that it was on the right track, I could type this integral into my calculator, which does sort of a form of trapezoidal rule, and see that it's pretty much the same. That'd be a good check for communication justification. Question 3, first one's pretty straightforward. Evaluate the definite integral using calculus and give your answer as an exact value. See how it doesn't actually ask for area at all, so we just need to integrate like we've done all year. I'll start by integrating this function. It's 1 on x plus 7. The derivative of x plus 7 is 1, so that means I know the integral will be natural log of the thing on the bottom. And I'll evaluate that between 0 and 3. So sub in my values, 3 plus 7, so subbing in 3, and then subtract the thing with 0 substituted in. Okay, and from here a lot of people just put it into their calculator, but see how it says as an exact value. So I'll use my log laws, natural log of 10 divided by 7. That's the exact value. In part B, it asks for the physical area. So we need to actually graph this thing between those bounds and see what it looks like. So if I was graphing this function, it's a cosine function. So I've got y, x, cosine, and there's amplitude of 2. And the period is going to be pi. Okay, because my period is 2 pi on b, and my b value is 2. I get a period of pi. So when I draw this thing, it's cosine, so it starts at its maximum value. It's going to look something like that. And this is halfway, even though it doesn't look halfway on my graph. It says find the physical area. So here's a positive area, negative area, and a positive area. So I'm going to need to integrate between those bounds. So I need to find what this point is and what this point is so I can do my integration. So I'm going to start by finding if there's any x-axis intercepts. And I'll do that by setting the function equal to 0. Okay, divide both sides by 2. And again, I'm on my unit circle looking for where the x-coordinate is 0. So I see it here and here, which are pi on 2 and 3 pi on 2 radians. So my 2x value is pi on 2 or 3 pi on 2. I could continue, but I know I'm only interested in solutions between 0 and pi. So my actual intercepts are going to be pi on 4 and 3 pi on 4, which makes sense when we look at our graph. So what this means is when I'm trying to find this physical area, I'm going to have to integrate between 0 and pi on 4 of this function. And then from pi on 4 to the next intercept of the same function. And then from 3 pi on 4 to pi of the same function. Because I'm lazy and I don't want to have to think about whether some of these are positive or negative or both, the way I'm going to get around it is by finding the absolute value of all of these. So if they end up negative, absolute value sign will change them to positive. So here it's going to be a bit of a mess, but note on the question paper it says you can only use your calculator for integration in maps problems. So I'm going to have to integrate by hand. Cosine goes to sine, and I need to divide by 2. So that 2 is going to get cancelled out when I divide by the differentiation of what's inside here, the 2x. So it'll just be sine 2x between 0 and pi on 4. And I'll be able to do the same thing for these other 2. Now I'll substitute in all the bounds and then evaluate. I should be able to do pretty much all this just using unit circle, looking for the y coordinates. I'll probably make some mistakes though. So it's just reading them off the unit circle when you simplify the fractions. So I'll end up with absolute value of 1 plus absolute value of minus 2 plus absolute value of 1. So I've got positive, negative, positive. All of these are going to change to positive once I take absolute values, and I'll end up with a physical area of 4 units squared. Does that sort of make sense? Yep, positive, negative, positive areas. Okay, so there's a fair bit in that question, okay, but just keep in mind the general idea is when you're finding physical areas, find any x-axis intercepts and then use them to determine the bounds that you're going to integrate between. Question 4 is a similar question to question 3, finding the area enclosed by all these places. When it tells us these two lines, x equals 2 and y equals 5, if I graph these, this is really just, this is x equals 2, and this is x equals 5. So this is just really telling us what the bounds are. Okay, and y equals 0 is the x-axis. Okay, so it's really asking me to find integral between 2 and 5 of this function. So just like in the previous example, I'll need to find whether there's any x-axis intercepts, okay, in that domain. So they occur when y equals 0. So I'll see if I can find any solutions to this equation. And I'm interested in, are there any solutions to this equation between 2 and 5? Because that's the domain that I'm integrating between. I'll try and do some factorization. So 2 numbers multiply to give 4 and add to give minus 3. 2 times 2? Nah. 4 times 1? Well, they both need to be positive or both need to be negative. Okay, can't factorize. You can keep trying if you want. Okay, so from here, I'll probably go to graphics calculator and into equation mode to try and solve it. So it's polynomial second degree. Put in my coefficients. 1 minus 3 and 4. No real roots. What does that mean? Okay, maybe I'll graph it and see what it looks like. Okay, I'll type it into graph mode and look at it. Okay, no real roots, so it's all good. I can just integrate in one go. Okay, because essentially my function looks something like this. I'm integrating between 2 and 5 and the y-axis, correction, the x-axis. So I'm trying to find this physical area. Okay, so this is a bit of a gimme problem. Area will just be the integral of this guy. Okay, but it is important that I've checked here and I've made some statement saying no x-axis intercepts in that domain. If I wanted to be extra cautious, I could put absolute value signs around that as well, just in case it was a negative one, but I've seen that it's a positive area above the x-axis. So integrating, increasing the power by 1 and dividing by that new power all the time. And now it's the case of substituting in these values. So substituting in 5 everywhere. And then subtracting, having 2 substituted in there. And we'll put this all into our calculator and get something like 19.5 units squared. Okay, so that one was relatively straightforward. Probably could have done that last term. Question 5, find the area between these two curves, f of x and g of x, using calculus methods. It doesn't tell us any domains. Okay, if I had 2 functions and it told me the domains that we wanted to integrate between these 2 points, then I could just write down my integrals. However, it doesn't tell me the domain, so it's a good idea to graph it and have a look what it looks like. So I'll graph both of these functions to visual what it looks like, and it looks something like this. Okay, so I'll paste this in. Hopefully by this stage we know that the positive one is x squared plus 1 and the negative one is minus x squared. And we want to find the area between those 2 curves. Okay, literally the shaded area. So I first need to find where my intersection points are. Okay, which are going to occur when the function values are the same. So when these 2 functions have the same value. So I'll try to find when this is. I'll bring all the numbers to the left and all the x's and x squareds to the right. And I should be able to solve for the intersection points. Okay, so my 2 intersection points are at -2 and +2. So that's now telling me the bounds within which I need to integrate. So I can find the area between the curves, which will be the integral between -2 and 2 of the top function minus the bottom function. So I like to do that just off to the side. The top function is 9 minus x squared, and the bottom function is x squared plus 1. I put it in brackets because I'm subtracting more than one thing. Expand that negative, and then collect like terms. So I really just need to integrate between -2 and 2 of this function. And that'll give me the area between the 2 curves. I'm a little bit cautious, not too confident I've got my top and bottom right, so I'll just absolute value it just in case. So I'll integrate. And then I'll just go to substitute in 2 and -2, just like we've been doing in all these other problems. So 8 times 2 minus 2 times 2 squared on 3, and then subtract 8 times -2 minus 2 times -2 squared on 3. Okay, put all this through my calculator, and I should get something like 64 on 3 units squared. Oh, you might have something like 21 and a third. Okay, but that's all good. So that's area between curves. Question really just requires us to understand what's going on in the problem. So it says a water trough is a prism with parabolic cross-section which follows this shape, and it's 50 centimeters at its deepest point, and the trough's 3 meters long. So when I read this, I'm thinking a trough, so like a drinking container for animals, looking something like this. Give it an open sort of lid as well. This parabolic cross-section is following this equation. Okay, I know that it's 50 centimeters at its deepest point, and I know that this is 3 meters long. So my real challenge is to try and find this shaded area of that parabolic cross-section. Since I'm in maps territory, I'll graph it on my calculator and see what it looks like. Can't really see anything. Better zoom out. Better keep zooming out. Okay, no good. Maybe auto zoom. Yeah, okay. I've got an idea of what's going on now. Okay, so I might just copy this graph into here so I can scribble on it. So that's what the parabolic cross-section looks like. However, it's only 50 centimeters at its deepest point. So if I can find what the coordinates of this minimum are, that'll give me an idea of what to do with this 50 centimeters. Okay, because all we really want to put, zoom in on this, I really want to put 50 centimeters above here, and then have a line going across there. And that'll be my parabolic cross-section. So if I go back to my calculator, I'll find the minimum. So G solve for the minimum, it's at 40.85. Correction, 40 negative 85. Okay, so I really want to find that shaded area. So on my calculator, I'm going to also graph this horizontal line, which is really y equals negative 35. Okay, it's 50 above the minimum. Okay, so this is now turned into an area between curves problem. So I need to find the intersection points, which will be at 10 and 70. Okay, so the cross-section area is going to be the area between 10 and 70 of whatever the top minus bottom function is. Okay, I normally do it to the side, but I'll just do it in here. My top function is minus 35. Okay, we can see that one's on top all the time. And my bottom function is this big one. Big fraction one. And I'm integrating that with respect to x. And since I'm cautious, I always put absolute value around just in case I got the top minus bottom incorrect. Okay, since I'm in maps land, I'll do the integration on my graphics calculator and type the whole function in, make sure I've got the dx at the end, and put in my bounds. I'll get 2000 as my cross-sectional area. Okay, I'll state that this is from the graphics calculator, and the units of this, since everything's in centimeters, is centimeters squared. Okay, I'm going to be finding a volume of this trough, which is going to be my area of the base times the height, because it's a prism. Okay. I note that my height is going to be 3 meters. So I think it's a good idea at this stage to convert this to meters squared. And remember, to do this conversion, centimeters to meters, I normally divide by 100. Since there's 2 dimensions, I need to do it twice. So I'll get 0.2 square meters as my cross-sectional area. And I'll end up with 0.6 meters cubed as my volume of my trough. Let's find the volume of water that can be contained in the trough. Since it's talking about volumes of water, sometimes it's a good idea to change this into liters as well. Okay. Meters cubed to liters. I know that every meter cubed is 1,000 liters. So I'll end up with 600 liters. I can make some statement here. The volume of the trough is 600 meters. So in all these problems, it's a really good idea to graph it to see what's going on and see what sort of things you can do to try and find cross-sectional areas, or whether you're trying to find area at all to find a volume. All right, good luck.